And I am happy to announce our next speaker, Professor Danielle Sinnett, professor in sustainable built environment with over 20 years experience of researching green infrastructure, including the generation of brownfield and contaminated land. She is also the director of the Center of Sustainable Planning and Environments at the University of West of Environments at Bristol, UK. This is the second presentation of Professor Sinnett at our conference, and today she will present about restoring compacted soils for trees.
Great. Good morning, everybody, and thank you again. You have to listen to me for a second time. So this research that I'm going to talk about is quite old, actually, and I didn't do it while I was at UWE. I used to work for Forest Research, who in the UK, essentially, they're the kind of research agency of the Forestry Commission, who own the sort of state-owned forests and woodlands in the UK. So this was quite a long-term 5-year trial of tree establishment on a restored mineral extraction site. So the reason that we were doing this research was at the time, and I guess it's had a bit of a resurgence in the last few years, there was quite a lot of government activity around reclaiming sites, either that had been used for mineral extraction or, you know, past industrial sites and those kinds of things. And there was a big kind of government push on greening those sites for community woodlands and other sort of soft land uses, mainly in areas where there wasn't the inward investment for, you know, built uses like housing or whatever. And but one of the main reasons why trees particularly failed to thrive on those types of sites was because of the soil compaction. And obviously we know that this is, you know, also an issue in agricultural and kind of traditional forestry soils. So there was lots of guidance at the time, and there still is, on, you know, how we can, you know, counteract poor soil handling, storage and placement. But, you know, as is very similar now, that it still happens. So we still, you know, despite everything that we know about how to remove soils and store them and then replace them after mineral extraction, or if it's a brownfield, if it's a post-industrial site, how we introduce, you know, reintroduce topsoils, for example, following contamination removal or remediation, you know, people still don't do it right, and so we still get these compacted soils. And so when they're in position, you know, we need to do something to alleviate the compaction. So the guidance in the UK is, for trees, you need a rootable soil with a bulk density of less than 1.5 to half a metre, and then 1.7 to a metre. And, you know, even in agricultural systems, you still, if you don't have a good rootable profile, you will get compaction below the roots, which will cause problems with waterlogging, etc. So, you know, the recommended method, if you've got no soil, is loose tipping. But where there's already compaction, we wanted to look at the sort of, you know, what you do if you haven't loose tipped, you've got compaction, what you then do about it. And at the time, and still, this is still the case, there was, you know, the recommendation was complete cultivation to 1 metre. But industry like using industrial ripping. So, but it's because it's cheaper and it's quicker. But the problem with that is that the soils recompact, which causes problems, particularly for trees. And often those problems aren't evident, you know, immediately, because you know, we need to wait for the trees to grow a bit. So essentially, this trial was to test a new ripper, the megalift, against both industrial ripping and complete cultivation. So this new ripper was developed to be as cheap as industrial ripping, but as effective as complete cultivation. So just to let you know where the trial was, so this is a map of England and Wales showing the kind of main mineral extraction sites, and the big star is where Bramshill Quarry is, which is an active and it's still active now, sand and gravel quarry that's been extracted for about 50 or 60 years now. You can see the image there in the inset, you know, the kind of the rows of trees. That's where the site has had previous extraction that's been reclaimed, and the site is where that red outline is. However, now it looks like that. What happened was we did the trial, and then it was supposed to run for a bit longer than it actually did. And what happened was one weekend, some people got into the site and they dug it all up and used it for like trial bike racing, you know, the little motorbikes. So which was, as you can imagine, pretty frustrating. So you know, this is what it looks like now. This is quite a recent aerial image, whereas obviously when we were doing the work, it didn't look like that. So in terms of the experimental design, so the soil had been removed and stored on site during extraction. And then as part of the restoration, the kind of normal practice at the time was followed, which was that ridges were created and then they were cross-ripped to 1/2 metre using a normal ripper, and then left for a year. And so our study area, which I'll show you in a second, so that the soil looked like the kind of image that you've got in the photo. And the study area was 2 areas, a disturbed area and an undisturbed area of 3 blocks each, which were divided into 15 plots. So you can see this here. So the kind of yellowy orange side is the disturbed plot, where we did root investigations and assessed penetration resistance, and I'll go through that in a second. And the green side is block 3. Sorry, is the undisturbed block where we took tree height measurements. So there were 15 strips within each side, and within those 15 there were essentially 3 blocks. So you had 3 blocks of 5 strips, and then the 2 sides. And so each strip, so where you've got those numbers 1, 2, 3, 4, 5, etc., that was a cultivation method. And then within those, I'll just quickly, no I won't, within those we had 4 species, but I'll go through that in a sec. So the 5 treatments that we used was standard industrial ripping to one, use just 1 pass, so the ripper just goes once to 0.9 meters. Deep ripping using the megalift, 2 passes, and then 4 passes, so backwards, you know, kind of up and down 4 times, again to 0.9 meters. Complete cultivation to 1.1 meter, and I'll show you a diagram in a sec of what that is. And then an unloosened control. So this was just the image that I just showed you, where it had just had the ridges and then been cross-ripped to 1/2 meter. And then the treatment type was randomized within each block. So where you have these numbers 1, 2, 3, 4, 5, the treatments were randomized within that. So block 1, the ordering of the cultivation treatments was different from block 2 and different again in block 3, and the same in the disturbed site. And then we had 4 species, which were in each plot, it was divided by 4, and we had those 4 species that you can see there: Italian alder, Corsican pine, silver birch, and Japanese larch. And these were picked basically to provide a mix of the type of species that were normal on these restored sand and gravel quarries, or in kind of woodland creation at the time. And the ordering of the species was slightly different between the disturbed and the undisturbed, and I'll show you that in a sec. But essentially there were 49 trees per species and 3 replicates per treatment. So this is an image of complete cultivation. I'm not going to go through it. It's more there for interest. So essentially the soil is removed and it's put to one side, and then it's sort of sprinkled back in, and then just kind of leveled off quite gently, and then the digger moves to the next strip without re-trafficking over the finished profile. So you're kind of working progressively in strips. So this is just to give you an idea of the surface finishes. So you've seen the control already. So this was just with the 1/2 meter cross ripping. The complete cultivation looks more. Sorry, I've got an ill child at home. Ellie, I'm in a meeting. He's gone to take Luca to school. Sorry, everyone. So the complete cultivation looks like this. So you've got, quite a level soil profile, and you can probably see there it's quite loose on top. And then this one's the 4-pass megalift. So, I guess kind of more even than the control. And then we looked at the profiles after cultivation. So we used a spray paint to see where the compacted areas remain. So you can see the control, the compacted area is quite high in the profile. And then the megalift, you can see, the industrial ripper, you can see where the tine marks are. The complete cultivation and the 2 megalifts give, a more even decompaction. So as I said, within each plot, there were then these different species mixes. So in the undisturbed, that was used just to measure tree survival and growth, essentially the species were completely mixed and kind of were next to each other. And then in the disturbed side, we had them in blocks like this, and the ordering of those species was randomized as well. And the reason that we did it like that is because of this, using these in more intrusive methods. So whereas in the undisturbed, we were just using unintrusive methods, just measuring tree height and growth and diameter. In the disturbed site, we measured penetration resistance using a cone penetrometer. In GS is, so PR is penetration resistance, RD is root development, and GS is growing season. So we measured across 2 trees in each kind of subplot. In growing season 1, we measured penetration resistance using a cone penetrometer and root development, and I'll show you in a sec how we did that. And then we did the same in year 3, so leaving a row that might have been disturbed during the work, and then the next row we did the root development work on, and then again in year 5. So we've got every other year root development and penetration resistance. And then we also did penetration resistance only in growing seasons 2 and 4. So we had annual penetration resistance, and then we also to trial a drop hammer to see how what the results of that would give us in terms of basically the penetration. The cone penetrometer is quite expensive, and it's quite difficult to use and get the data from. I mean, this was 20 years ago, so I'm sure there's better versions available now, but the drop hammer is much easier to use. So we also did a sort of smaller experiment looking at the correlation between those 2 measures. So we did drop hammer measurements in growing seasons 4 and 5. Okay, so as I say, we measured penetration resistance using the cone penetrometer and the lifting driving tool, and then we measured tree growth and survival. And then for root development, we essentially dug a trench that was 1 meter deep along the side of 2 trees, as close as we could get, and then mapped using essentially cocktail sticks the roots that were protruding from the face of that trench, and we used calipers to measure the diameter of those roots as well. So what you ended up with was something like this, you can see here, which we could then plot and run the statistical analysis on. So we could see the kind of distribution of roots along that face and their diameter. I'm not going to go into the stats in a lot of detail because a colleague actually carried the stats out, but essentially in both undisturbed, in the undisturbed plots, we removed the replacement trees and the guard rows. So the rows around the edges of the subplots and any trees that were replaced were excluded from the analysis. Tree survival was analysed using generalised linear models. And then the tree height data was analysed using ANOVA with t-test to compare between individual species and cultivation methods. And then for the penetration resistance and the tree root development, because it's a depth measurement as well, we used REML analysis to look at the differences between depth, cultivation treatment and species. In the case of penetration resistance, species wasn't significant, so that was removed from the final model. And then again, we used t-tests to look at the difference between the cultivation treatments. So going through the results, kind of one measurement at a time, the penetration resistance measured during the cone penetrometer. So we've got a line in the middle there at 2, so 2 megapascals is kind of deemed to be the point at which you get root, you get good root development. So that's what we're sort of aiming for. And you can, a bit below 2 is what we're aiming for. So you can see that only the complete cultivation achieves that less than 2 megapascals penetration resistance to a depth of 0.5 meter. I should have mentioned actually the other issue with the cone penetrometer is it only goes down to half a meter, whereas the lifting driving tool goes a lot deeper. So if you're looking for decompaction at depth, you want that depth in the measurements. So there was a difference between the different cultivation methods. As you would expect, penetration resistance increased with increasing depth. And the kind of ordering was that the control had, as we would expect to see, the control had greater penetration resistance than the industrial ripper. There wasn't any difference between the industrial ripper, the 2-pass or the 4-pass megalift, and then the complete cultivation achieved more decompaction than all the other methods. And then very, very similar findings with the lifting driving tool. So you can see on the kind of y-axis there, the depth that we achieve goes down to 1.1 meters. So we get a much clearer overview of the depth. And you can see again there that down to about 0.5 meter, or maybe just over 0.5 meter, about 60 centimeters, there's very little difference between the megalift and the complete cultivation. And also with the 2-pass megalift, but at depth we start to see quite big differences between the different methods. And then looking at tree root development, so these are the results for year 5. So this is the kind of longest root development that we've got. There aren't any species differences, but we do see that all of the different kind of ways of measuring root development were significantly different between the treatments. So maximum root depth, the total number of roots, and the average root diameter, and the percentage of fine roots and the percentage of coarse roots were all different. So what we see there is, generally speaking, that all of the cultivation treatments achieve greater root development than the control. But that complete cultivation achieves greater root development than most of the other treatments using some measure. So in maximum root development, what we see is everything is better than the control, and complete cultivation is better than the 2-pass megalift, but the same as industrial ripper and the 4-pass megalift. And that's, because the maximum root depth, that this soil is very, very stony because of the sand and gravel extraction. So, one root can get quite deep by going around stones, but that doesn't tell you much about the kind of overall root development. And then with total number of roots, again, all better than the control, but in this case, the complete cultivation is better than the other non-control treatments, and there's no difference between them. And then the same with the, or very similar with the average root diameter, the complete cultivation is better than the control, or in fact all the treatments. And then the 4-pass megalift is the only other one that's better than the control. And then percentage of fine roots. So what we want to see is lots of fine roots, because when you get compacted soils, you get very, very coarse roots, which make trees much more vulnerable to wind throw, etc., and inhibit their water uptake. So what we want to see is what we've got here, which is the percentage of fine roots in the complete cultivation is greater than the control and the 2-pass megalift and the industrial ripper, but no different from the 4-pass megalift. And the percentage of coarse roots is the reverse of that. So we've got much higher percentage of coarse roots in the control and the other treatments compared with the complete cultivation. And so just to give you an idea, so you can see visually the kinds of things that we were seeing. So this is after, again, 5 years. So you can see here the distribution of the roots is very, very different. So if we look just first at the control and the complete cultivation, you can hopefully see there that we've got this, concentration of very coarse roots, only down to about 30-40 centimeters, whereas in the complete cultivation, we've got a much more even distribution of roots and including those fine roots. And then the 4-pass megalift and the industrial ripper are kind of, similar to the control. We've got lots more fine roots. We're not getting the depth or the uniformity of the depth. So we're getting a few odd roots coming down, but there's nowhere near the distribution that there is in the complete cultivation. And then turning to survival and growth. So I guess this is the bit, the bit that we can see. So survival, cultivation, treatment and species is both are significant. The survival after 4 growing season was generally pretty high. And all cultivation treatments had greater survival than the control for at least one species. And complete cultivation was better than all the other treatments for Italian alder and 4-pass megalift, but only for Corsican pine. So it's quite variable in terms of the results for survival. But looking at tree height, species was significant for all years, which you would expect to see. Species grow at different rates in any soil. And the cultivation treatment was significant from year 2. So in year 1, we weren't seeing those differences. It was as the trees matured that the impact of this compaction at depth and the recompaction of the soil materialized. So all cultivation treatments had greater tree height than the control for most species. And then looking just at the 4th growing season, the 2-pass megalift was the same as the 4-pass and the industrial ripper for Japanese larch and Corsican pine and birch. And the 4-pass megalift was better than the 2-pass, the industrial ripper and the control for Italian alder, but the complete cultivation was better than all other treatments for all of the species earlier on, and then from Corsican pine as well from the 4th growing season. And so then just a quick image here. So thinking about the cumulative growth over that time, we see very, very similar results. So you can see here that the kind of the complete cultivation line is extending as time progresses. That gap is getting wider between the complete cultivation and the other methods. So the other methods are, they're still offering some improvement on the control, but we're not seeing the growth that we would see in the complete cultivation. And I guess what we were expecting to see was that as the trees matured, these gaps got wider. But as I say, some people destroyed our plots. So just to conclude, so the megalift is effective at alleviating some of the soil compaction to a depth of around 0.8. but this, you know, we still were seeing quite high penetration resistance at shallow depth, so roots were kind of able to go around stones, and we didn't see that uniform root distribution that we saw in the complete cultivation. And I guess, yeah, that, you know, our kind of high level finding is that complete cultivation is still the most effective method. You know, it is more expensive, but you do get that more sustained tree growth over time. And as I said right at the beginning, prevention is better than cure. So what we would hope is that we wouldn't get in the situation where we have compactor soils in the first place, but where we do, complete cultivation is by far the most effective method of alleviating them. And there was a few papers published at the time from this work. So one of them is looking just at the penetration resistance. One of them is looking at penetration resistance and the growth and the tree root development, and then the other one is looking at this correlation between using the two different penetration resistance measures, the cone penetrometer and the lifting driving tool. And that's it. Thank you. And thank you for having me a second time.
And thank you very much, Dani, for finding the possibility to speak and deliver this second lecture, which we appreciate a lot. So now I invite participants to ask their questions. Please unmute yourself and ask. Okay, and while we are waiting for the first question, I can ask mine. So as I understand that complete cultivation is quite demanding method. What kind of machinery is used for that? Like, is it any specific these excavators, or is it something which like commonly, let's say, available in the community?
I would say it's not something that is commonly available in the community, but it is just using a kind of standard large digger that you would see in, you know, sort of normal construction sites, if that makes sense. Mm-hmm. I can probably find in the papers, it tells you exactly what machinery was used, but I'm afraid I can't remember right now. I can have a quick look if you like, but it's, you know, it's a standard kind of JCB digger, mm-hmm. but larger than those, you know, like the mini diggers that you get that are for more so like small that's what lands. I wanted so it's, yeah, it's mm-hmm. bigger than that.
I understood.
But mm-hmm. not anything special.
Mm-hmm. Okay, I see. And now I see the raised hand. Yep. So please go ahead, unmute yourself and ask.
Hi, Danny. Thank you so much for your wonderful presentation. I am curious if before this study, you guys have looked at any biotic ways to decompact the soil. If so, have you found any before doing the study? Like
no, I mean, we were just focusing. I mean, I guess this was, you know, there had been other studies using, again, not biotic methods, using these kinds of methods on different types of restored soils. So this was a kind of, I guess, a kind of continuation of that, just to trial this new megalift that was being kind of offered as a, you know, as a cost-effective but as good as complete cultivation method. So no, we were only looking at these methods. I mean, I think there has been, you know, certainly in the UK, the kind of the recommendations for agricultural soils is that you plant deep rooting species every so often to kind of alleviate any compaction. You know, what you don't want is to keep planting the same shallow rooting species all the time, because then you get this compaction at depth. But I haven't looked into those, no, sorry.
No worries, thank you.
Thank you. So I just like imagining in Ukrainian scenario, so I could imagine that this high soil compaction can occur in shelter belts where the troops are located for a long time and maybe establish their trenches. And because like these shelter belts, these are not productive part of the landscape, and of course we cannot invest a lot of resources in restoring this. So I wonder if we okay, let's say at what depending at what level of compaction should we like switch from reaping to complete cultivation, and if we do need to use this complete cultivation, is it possible to minimize the scale of using it? Let's say if we do it like on a narrow trench, hoping that after trees established in this trench, it can gradually move its roots to the side where the soil is compacted, but it will be already in a better situation to explore this compacted soil.
Yeah, I mean, I guess, so I think it depends on what you want to plant. So, you know, if you know, trees will need a rootable profile, and if you you know, I guess if you think about what happens in an urban environment, we now see that these kind of crate systems exist where you have almost like a, sorry, I'm kind of moving my hands around, nobody can see that. You have a you know, essentially a kind of cube that goes underneath the pavement that is filled with soil that the tree roots inhabit, and though, you know, those restrict tree root development, but they provide enough of a rootable profile that the tree's health isn't inhibited. So I guess if you kind of adopt a similar principle, as long as you've got, you know, a few meters around where your trees are going to grow so that their roots can spread without then making the tree vulnerable to high winds and that kind of thing, then that should, in theory, be fine. I mean, trees, we've done work on or again in my last job, we did work looking at tree development, root development on landfills, for example, and where you have these kind of engineered clay caps and then the soil above it, as long as you provide enough rootable material above the clay cap, the roots have got somewhere to go. They won't try and get into the clay cap as long as they're able to get what they need from the soil. So, you know, in theory, I think, yes, you would, as long as you've gone wide enough and deep enough for the trees that you want to plant, you don't need to go beyond that. Does that make sense? I mean, I think, you know, there are other reasons outside of tree root development or any plant development for not having compacted soils, though, in terms of surface water flooding and those kinds of things. So I think, again, it's going to be quite site specific. If it's in an area that is vulnerable to flooding, you would probably want to alleviate the compaction kind of almost irrespective of whether or not you're planting deep rooted species. I mean, we've had quite a lot of problems in the UK with agricultural soils being compacted and causing quite high levels of flooding, where the water doesn't essentially have anywhere to go, and it's flooding urban areas. So, you know, it isn't just about the root development, but yes, in theory. And then in terms of your first question, I mean, I think, you know, using those numbers that I showed you at the beginning, you know, less than 1.5 grams per meter cubed for the bulk density down to 0.5 meter. If your soils aren't that compacted, you can probably get away with using less intrusive methods. But obviously putting the ripper across them is, you know, you're re-trafficking over it using the prime mover that's dragging the ripper as well. Whereas the complete cultivation, you don't traffic over the soils at all. Does that make sense? Does that answer your question?
Yeah, now I understand better. Yeah. Thank you. And is there any other questions from participants? Okay, then I can ask because we have time.
That's fine.
I can benefit from asking more questions to you. If you would apply your finding to plow pen, or maybe you or some other colleagues can correct me, but I imagine that in the eastern Ukraine, where we have this Chernozem, black soil, the depth of the soil is quite thick, and this plow pan could be quite deep. Which, if we need to break this plow pan, which method would you recommend?
I mean, I haven't worked on agricultural soils. I don't think
see.
it's normal to use complete cultivation on agricultural soils. This is really where there is very severe compaction, you know, on these sort of mineral extractions. And I mean, I think I don't know, somebody else can correct me that maybe knows more about agricultural systems, but I would imagine just the sheer size of some of those sites would make it quite costs, you know, that it would make it quite prohibitive in terms of just the practicalities of it. I mean, I'm not sure. I've not heard of complete cultivation being used in agricultural systems. It's more for where you've got very, very severe compaction, like I mean, maybe the you know, the photos didn't do it justice, but you couldn't even get a spade into this soil. It was so hard. Without, you know, in the control soils, it was very, very difficult. Using the lifting driving tool is basically like a kind of metal pole with a big weight on the top that you kind of slide up and let drop, and even that, you know, you were kind of letting it drop and it was moving like, you know, a millimeter at a time in these very very compacted soils. So they are, you know, it is quite extreme. Yeah, I don't know if anyone else wants to come in on agricultural soils.
Thank you. Yeah, if there are any questions, please unmute yourself and ask. Okay, maybe then I ask my final question. Does it make a sense to cultivate, like initially cultivate some like hardy plants which develop very strong taproot to loosen a little bit the soil before you apply this mechanical cultivation? So, I mean, this is theoretical question. I just guess, is it like theoretically possible or not?
I mean, certainly on these types of soils, no, because they are just so compacted. And so, you know, when, I mean, obviously our focus was the trees, but even, you know, particularly in the plots with Italian alder on them, there was quite a lot of natural regeneration, you know, because they're you know, they're fixing nitrogen. There was quite a lot of, you know, just other kind of grasses and you know, gorse and those kinds of things around the trees. And when we were doing the excavations, you know, you weren't getting any root development below you know, 30 centimeters or so in those control sites. I think it's more that, you know, certainly the kind of the guidance for agriculture is more that where you do decompact, you then plant deeper rooting species to maintain that decompaction so that you don't get recompaction over time, which is one of the problems with the ripping, is that the soil kind of slumps back in again. And so it recompacts. So I think it's more that if you spend the money on doing any form of decompaction, that you immediately plant quite a fast deep rooting species to basically allow the roots to develop before any recompaction can take place. Does that make sense?
Yeah, totally. Thank you very much.